Now let's look at how to know whether this particular structure here is an aromatic or anti-aromatic or non-aromatic compound. Now the basic thing to note first is that we have to check whether this compound is cyclic there, and that's the first condition. Is it cyclic? The second is it planar? And the third is it conjugated? Now it's becoming more interesting here. Now for it, is it cyclic? I have not written the fourth one because that's where we will perform our mathematics and we will confirm if it is aromatic or anti-aromatic, because the Ockel's rule is the one that differentiates the aromatic from anti-aromatic. Now the first thing to know is it cyclic? Yes, this compound here is a cyclic compound, hence it has ticked that condition. The second one to know is this compound a planar compound? Yes, this compound here is a planar compound. The last video I told you guys that whenever you want to really know whether a compound is planar or not for a cyclic compound, whenever it has number of atoms within, or number of carbon atoms within 3 to 7, then that compound is automatically a planar compound, that is, it is flat. But if it has more than 7, it does not mean it is not a planar compound. It can either be a planar or non-planar. Now to look at this compound, if you count the number of carbon at every edge, we have carbon atom here, we have carbon atom here, we have carbon atom here. That's 2, 3, 4. And this means that this compound is a planar because it is between the 3 to 7 carbon atoms rule. So hence it has ticked this man also here. The last one is conjugated here. Now it is a conjugated cyclic planar structure. Why? Because if you check out, each carbon atom is attached to a double bond. This carbon atom here is attached to this double bond. This carbon atom here is attached to this double bond. This carbon atom here is attached to this double bond. This carbon atom here is attached to this double bond. And I told you that whenever we have a case of heterocyclic, how do you know? This lone pair makes it conjugated because there is space for p orbital. So hence it has ticked this man also here. Now the mathematics now goes to, does it follow the Ockel's 4n plus 2 rule? Once it follows this man here, it is an aromatic. But once it follows this one here, it is what? Anti-aromatic. Now let's check. For us to know whether or what a pi electron is or what pi electrons are, we already know that for a double bond, it consists of one sigma bond and one pi bond. And we know that whenever we have a bond, one bond consists of what? 2 electrons. That's just the basic there. Whenever you have one line like this, it simply consists of what? 2 electrons. So that's just it there. So and we know that double bond consists of one sigma bond and one pi bond, and that one pi bond is what we are concerned about. That one pi bond will consist of 2 pi electrons. So that's where it gets interesting. Now to this compound, if you are to check whether this compound, if you are to check the total number of pi electrons in this particular compound. Now I already explained in the last video that whenever we have a lone pair for heterocyclic aromatic compound, whenever we have a lone pair facing inside this ring, we count it as part of pi electrons. You understand? But whenever we have the lone pair outside, not inside this ring, we do not regard them as what? Pi electrons. Because once they are inside, they contribute to the stability of that compound, and we know that aromatic compounds are very, very stable due to the delocalized pi electrons within the ring. Now let's check the number of pi electrons here. The first thing first, we have a double bond here, and we have a double bond here, and we have this man here facing down. Hence we can say from this one here, this one contributes 2 pi electrons. This man also here, the double bond here, contributes 2 pi electrons. Why does it contribute 2 pi electrons? Because the double bond consists of 1 pi bond, and that 1 pi bond will give us 2 pi electrons. Same goes to this point here. And this man here, we have lone pair outside there, and we have lone pair outside there. That is, we have 2 dots inside there, and we have 2 dots outside there. Hence we are considering this one. That is, this one also will be 1 and 2. That's 2 pi electron. That's just the basic understanding there. Hence, if you add them up, that is, we have what? The number of pi electrons as what? 6 pi electron. Now, if you remember in the last video on aromaticity, I explained that whenever we have some certain numbers of pi electrons for a particular cyclic planar conjugated compound, the compound will either be aromatic or anti-aromatic. I said it that when we have 2 or 6 or 10 or 14 and so on, it is what? Aromatic. But when we have something like 0, 4, 8, 12, they are what? When the pi electrons in that structure, we get it and we see that it is either of these numbers, then it is what? Anti-aromatic. Hence what we have here is 6 pi electrons. It is part of the aromatic pi electrons. Hence this compound has confirmed or has passed this last test. Hence we can see this structure here is what? An aromatic compound. So that's how to know whether a compound is aromatic or not. See you in the next video. Now let's look at this structure also. This structure here, let's look whether it is aromatic or anti-aromatic or non-aromatic. Now we have our 4 rules to check. We have the first thing, whether it is cyclic. We have the second one, whether it is planar, and we have the third one, conjugated, and we have the fourth one, the Ockel's rule. Now let's see. Now, is it cyclic? Yes, it is cyclic because this is a ring structure. Is it planar? If you check it very well, we can count the number of carbon atoms 1, 2, 3, 4, 5. It is within the 3 to 7, so it is also planar. Now that's good, it's going. Now, is it conjugated? That's where there will be problem. Now, if you check, conjugated means each carbon atom must at least be attached to a double bond, or perhaps if you have the case of heterocyclic, that elements like nitrogen, sulfur, oxygen must have lone pair that is inside the ring. Hence we count it as conjugated atom. Now for this man here, if you check this one here, this carbon here is not attached to any double bond. There's no double bond here, there's no double bond here for it to be conjugated. Hence this man here is not conjugated, but other carbon atoms are conjugated in this structure. But once one of them is not conjugated or is not attached to a double bond, this compound is regarded as not what? Conjugated. Hence, for it to have even failed this man here, for it to have even failed this conjugated atoms test here, it is automatically non-aromatic. it is automatically non-aromatic. Now, why do I say it is automatically non-aromatic? For an anti-aromatic compound, it must be cyclic, it must be planar, it must be conjugated, and it has an Ockel's rule of 4n pi electrons. But for aromatic, it must be cyclic, it must be planar, it must be conjugated, and has 4n plus 2 pi electrons. But when we are talking about non-aromatic, it's not even conjugated, and if it's not conjugated, it is what? Non-aromatic. Some non-aromatic can be cyclic, can be planar, but once they are not conjugated, they are non-aromatic. You understand? So both anti-aromatic and aromatic compound obeys these first three tests, but when it comes to the Ockel's rule, it's kind of differentiate both of them. Hence, this compound here is a non-aromatic compound. Let's quickly look at one last one. If you have something like this, let's say we have something like this. Yeah, let's say we have something of this nature. Now let's say we have something of this nature. Is this compound aromatic or anti-aromatic or non-aromatic? Let's write our rule there. Is it cyclic? Yes, it is a cyclic compound. Is it planar? Now let's count the number of carbon atoms. 1, 2, 3, 4, 5. Yes, it is planar within the 3 to 7 carbon atoms, and it is a cyclic compound. Now, is it conjugated? It's becoming more interesting in this conjugation when a compound is conjugated. Now, if you take it out very well, each carbon atoms must be at least attached to a double bond, or the atoms there must have a lone pair that is inside. Now if you check this one is attached to a double bond, this one here is attached to a double bond, this one here is attached to a double bond, this man here is attached to a double bond, but this man here is not attached to a double bond. So this does not obey the conjugated rule. But I want to prove something. Let us put something like this here. For this compound now, this man here also has this carbon here also has conjugated. Is also conjugated because it's attached to double bond. And we have that the nitrogen that is here, it has a lone pair that is facing inside, hence it is conjugated. Now for the Ockel's rule. Let's see the total number of pi electrons that is there, and let us relate it whether to the aromatic. You know, for it to have even passed these three, it is now confirmed that it is either aromatic or anti-aromatic, because non-aromatic would have missed one of these three, and that's it. So now, if we are to know, let's get the total number of pi electrons that are there. So now, if you check the total number of pi, this one will contribute 2 pi electron. This man here also will contribute 2 pi electrons. This man here also will contribute 2 pi electrons. And we already know that for us to have a lone pair inside there, it also has, that's 1, 2, that's also 2 pi electrons. If you sum it up, it will be what? 2 pi electron plus 2 pi electron plus 2 pi electron plus 2 pi electron, that's 8 pi electrons. Now, this compound here, when you have 8 pi electrons, you must relate it to the anti-aromatic and aromatic. For aromatic, we know that it is 2, 6, 10, 14, and so on when we put our value for N as 0, 1, 2, 3. And for the that's aromatic oil, but for the anti-aromatic compound, we know it is 0, 4, 8, 12, and so on. Now, if you check it out very well, the total number of pi electrons for this particular compound is 8, and it falls within the anti-aromatic pi electrons. Hence, this compound there is what is an anti-aromatic compound. Now, one theoretical difference between aromatic and anti-aromatic compound is that aromatic compound is very, very stable due to the delocalized electrons, due to this number of pi electrons, but anti-aromatic compound is very unstable due to this number of pi electrons. So thanks for watching this video, and see you in the next video. Subscribe for more.